So today's topic has to do with urbanity, the particular characteristics or the whys and wherefores of the emergence of large urban spaces in the Neolithic Revolution. I've subtitled this Metastatic Neolithic Complexity because I want you to frame this in terms of how complexity replicates itself. How complexity requires more and more energy inputs, and how, because of that, it requires increasing degrees of complexity, okay? And let me explain that in a little bit more detail. This is something that comes from Christian's arguments. If you can recall that reading early this semester, Christian argues that complexity requires energy, but it needs to make more and more efficient ways to acquire that energy. And as it acquires energy, in order to prevent entropy, it requires more and more energy. And so once you have complexity emerging, it begins to replicate itself at larger and larger scales. So if you want to think about complexity and replication in, as kind of a metaphor, you can think about complexity as being a virus, or as replicating itself in a viral manner, insofar as it will, it can kind of subvert the abilities of other organisms. It'll subvert their ways of getting energy. It will subvert their reproductive systems, okay, in order to replicate itself, all right? In this sense, this is in the sense which I mean that complexity is, it metastasizes. It replicates itself rapidly. Or if you're more mathematically minded, you can think of complexity as fractal. As a matter of fact, the notion of complexity as fractal is an idea that Christian also puts forth. And you can think about fractals as a kind of system, or a way of a geometry of, for example, crystalline geometry that grows larger and larger scales of exactly the same structure, just at larger and larger scales, okay? So whichever of these metaphors appeals to you, please feel free to use it. And I want you to think about this in terms of, what you experienced in Bosses and Bost, where you're talking about small scale infrastructure, small scale relationships, small scale positive and negative reciprocity, systems of reciprocity. And that, as those kinds of systems in certain ecosystems will require greater degrees of energy, greater degrees of complexity, and then those are going to metastasize into larger and larger units, okay? Now, let's keep clear, okay? We are not talking about a linear narrative. I mentioned this in the previous lecture. We're not talking about human beings emerged from Paleolithic, they evolved to Neolithic, they evolved to, sedentary, they evolved to, urban states, they evolved to empires, okay? Subsistence agriculture, which is what you kind of modeled in Bosses and Bost, continues to exist now. Okay, there are plenty of places where they are only engaged in subsistence agriculture. Okay, and if you recall, this early agriculture emerged in particular locations. All right, doesn't emerge everywhere across the globe. As a matter of fact, it emerges in a particular sweet spot. If you think about the planet, okay, and that sweet spot is about 15 degrees south latitude, that's just below the equator, to 45 degrees north latitude, that's about halfway up the northern hemisphere, all around the belly of the planet, okay? And it's in that belt that agriculture, subsistence agriculture, emerges around the globe, okay? And there are reasons how come it happens there. A, it has to do with the impact of the shrinking of the ice sheets, but also because complexity metastasizes where one farming community exists, it will need more territory over time to secure its resources. Leaders are going to want more territory to satisfy the needs of their followers. And then that means that it becomes contagious. It begins to spread. And it's going to spread east to west or west to east around the belly of the planet. Why? Because A, the majority of land mass of the planet moves and that is, it exists in an east to west, west to east band, but also because agricultural technology, like the right seeds, the right types of plant materials, whatever, those are able to grow in similar ecosystems. And the similarity of ecosystems around the belly of the planet is greater than the similarity of ecosystems moving north to south on the planet. So if you are an agriculturalist in Egypt, it's hard for you to carry your agricultural technology, or for people down in South Africa to adopt your agricultural technology, because the ecosystems are too different. So moving in a latitude around the planet, you're having similar ecosystems. So that means that wheat agriculture can pass the same direction. Barley agriculture can pass it. The same crops are moving back and forth, okay? So, you know, it's in that sweet spot, a belt around the belly of the planet, where agricultural communities first appear and agricultural technologies begin to expand. And that's the direction in which people gain the resources necessary to support increasing degrees of complexity, all right? So I want you to understand that in the locations we're talking about today, all right, they're particular locations, but that subsistence agriculture exists around the belly of the planet, even in locations that don't get large-scale urban centers, okay? So let's talk about urban centers, all right? These are large-scale cities, okay? And as I'm making the argument, it's not a when does urbanity appear, it's a where does urbanity appear, okay? And this is my argument. Urbanity appears in areas with potential boom, potential for massive energy productivity, okay? And potential agricultural productivity with the least amount of energy inputs to access it, okay? So places of low forestation. We're still talking about a time before bronze, okay? Or maybe just as bronze is beginning to emerge. So low forestation is important, because if you're going to try to clear farmland with a stone axe, that's slow, okay? So a place that doesn't need a lot of clearing of trees. Areas of potential boom are places with gravity-based water access. So water that's going to flow downhill from hills, from mountains, from high above you. That way you don't have to pump water up, up out of a well or something like that. So gravity-based water access. Because it's gravity-based water access, that means that there's a lot of erosion, bringing sediments, silts down into the river valleys. That means you're going to have high soil fertility. So that means that you're in an area that it takes less energy to access the calories that are stored in that location, right? But it's potential boom, all right? Because you're going to get urban centers, especially in locations where you've got potential bust. That is, urban centers are going to appear where there's resource instability, massive resource instability, potential for boom, and then the potential for bust. And the bust is devastating. Okay, so you see them, the earliest urban centers appear around areas with catastrophic rivers. These are rivers that flood in a dangerous way. These are rivers that move in their beds unexpectedly. These are rivers that even to this day, break out of their channels and drown tens of thousands of people. Very, very dangerous river systems, okay? And you also have potential bust in areas where you have potential catastrophic weather patterns. And this has to do with the monsoon. I'm not sure if you know what the monsoon is, but it's a weather pattern where, high, dry, cold mountain ranges pull warm water, warm air patterns from over the ocean up into the continent, okay? And then it switches direction, right? The other half of the year, and the wind patterns go the other direction. And this pattern of wind going in one direction one season, turning around going the other direction the other season, comes with massive rain events and melt-off events in the high mountains, right? The high mountains, you get a lot of snow from that warm, damp ocean air going up into, say, the Himalayas. You get a lot of snowfall. And then when that melts, that water comes pouring downhill. If the monsoon doesn't arrive on time, if the weather pattern doesn't shift directions at the right time, that leaves people living in those river valleys waiting for the water to come downhill high and dry. So the timing of the monsoon is never certain, right? And because of that uncertainty, people have to figure out ways to deal with that uncertainty, and that requires complexity. It's the same with the catastrophic rivers, okay? If you're not going to have your village destroyed by a catastrophic river, you've got to have a plan to control the river, and that is what requires complexity. If you're living in a place with a relatively stable and predictable agricultural productivity, right, there's no need for higher degrees of complexity. I've already mentioned this before. Complexity is the result of some problem that can't be solved in any other way. People don't invent technology. They don't put in the energy to build dams and dikes because they've got free time. They do it because there's some crisis that they're trying to prevent. And so the crisis they're trying to prevent are the cycles of bust in an area with the potential for boom. Right? And if you think about the earliest urban civilizations, you probably know this, they happen in arid great river valleys, okay? And I have these images here just so you can see the similarities of the land masses that we're talking about, all right? This is the Tigris, right? And it's surrounded, by dry, low, see these, it's dry, okay? Low forestation, dry areas. So the earliest large urban centers start around 10,000 years before present in the Tigris Euphrates in Mesopotamia. Look, this is a Yellow River Valley in China, right? Look at that. There's very little in the way of tree cover. It's heavily silted. That's how come they call it the Yellow River, okay? And it's flat, all right? That's about 9,000 years before present, right? And the others are the Indus River Valley. That's in modern day Pakistan. And you get urbanization happening around 7,000 years before present. And of course, there's the Nile River Valley, which is also dry, flat, very little in the way of tree cover, 6,000 years before present. You get urban centers in these areas. So I'm trying to make the argument that these particular locations have the potential for boom, the potential for bust, and because of the instability of the weather patterns in the river systems, human beings have to develop higher degrees of complexity than they had in early small subsistence farming villages. You're going to get something different than subsistence farming villages in these regions. There are other regions on Earth where this happens a little bit later, but these are the first ones, okay? And that's what I wanted to cover in this piece of the lecture. I'm going to post a second piece that delves a little bit more into the peculiarities of urban civilizations. Okay, that's all.